at a recap of study unit 10 and 11. And basically tonight we're just going to look at examples. So again, some previous assignments, some previous exam questions. So gonna work through some of them, and then for Sunday session, Sunday at 9 o'clock, we will work through the self-assessment that was shared, I think, a day or two ago. So we'll then on Sunday work through the self-assessment. Okay, so let's get into some of the questions. Some of it you might have seen before. Some of it is also in the self-assessment, because you guys will just again see a lot of questions in the self-assessments over the last few years comes through in the assignments and in the exams. So again, just good that we cover as most of these questions as possible. Okay, so let's look at it. This is a question around chapter 10, so the chi-square test, and the question is, which one of the following statements is incorrect? So remember, there's nearly again 4 or 5 things that we can remember from the chi-square test. So let me just quickly get that, since we're now chatting about it, that table, that quick summary. Let me just quickly copy it out of that study unit, because I normally like that. Just this, because that's always a nice reference to have in the study 10 questions. So let's quickly just get the marker again. Okay, so the T-stat has R minus 1, C minus 1 degrees of freedom, where R is the number of rows and C is the number of columns. Okay, so that is true. The observed frequency for each cell is equal to row total times column total divided by n, where n is the sample size. Okay, so what they are telling us here is not the observed, but the expected. And so if we needed to work out the expected frequency, that would have been a perfect way of describing the expected frequency. So the expected frequency for each cell is equal to the row times column divided by n. Okay, so that is expected and not observed. Observed value is just the number that they will always give you. So the observed number is what they will see in the sample. So if this was a cross-tab between students studying stats and maybe economics, the observed will just be how many of the students are doing that. So then we will work out the expected by saying, okay, so what is the expected value of students for next year or something like that. So But for observed is what is the current status of what you are looking at. Okay, then the two variables are qualitative. So again, think about it as if we later get again to a table. So one of the variables might be what subject you study, so stats, maths, let's say science, and then one of the other things might be first year, second year, or something like that. Okay, so it is basically looking at two qualitative variables or more. But for what we need to do in chi-square, it is only looking at two variables. Okay. Then the null hypothesis is that the two variables are independent. Null hypothesis always independent. So that is true. The alternative is always the not independent. Then the last one, if observed and the expected frequency for each cell are equal, then the test statistic will be equal to 0. That is also true. So let's just say we don't need to worry what we are looking at. So let's say, because what they are telling us, so observed and expected frequency for each cell. So if that was 100, then they say, okay, well, the expected is also 100. That was 21. We can even just make up numbers, but let's just make sure that they are equal. And so if we read that again, so if observed and the expected frequency for each cell are equal, okay, so they don't need to be all four the same number. Those two just need to be equal, the observed and the expected. So if we then work out that t-stat, we will always say the observed minus the expected. So that will, if they are the same, it will be 0. So 0 to the power of 2 will stay 0. 0 divided by 100 will stay 0. So that will be 0, that will be 0, that will be 0. The fourth one will be 0. A sum of 4 numbers that are 0 will stay 0. Okay, so I just wanted to show that again because this one it starts off easy, but some of these are a bit more difficult. And this is nearly a very nice way of testing basically all of these inputs without talking about numbers or giving you a variable that they're talking about that one can make it more relevant. So this is purely a theoretical question that they have asked in this first one. Okay, so let's go to the second question. So in a contingency table with 9 rows and 2 columns, how many degrees of freedom are there for the chi-squared test. Okay, so we know row minus 1, column minus 1. So row is 9 minus 1, column is 2, so 2 minus 1. So we get 8 times 1, which gives us 8. Okay, so it is that option. Just check if you said it was 8 plus 1, you would have gotten a number. If you said 9 times 2, you would have gotten a number. If you said 9 minus 2 for some or other reason, there's also a number for you. Okay, so just be, again, careful with these questions. And you have again, it is open book. You're allowed to use your notes. So use this, print it somewhere, put it somewhere that you nearly have quick access to it, so that when we get chi-squared questions, you can very easily get to that. Okay, so let's look at the next one. So what do we need to do with this question? Okay, so now we're still talking about the previous question, but doesn't really make too much difference. Now consider a contingency table with 9 rows and 2 columns in a chi-squared test of independence. Okay, so we know that the degrees of freedom is 8. And then the level of significance is 1%. Okay, so with this, I now need to go to the T table. Let me quickly open the T table. So again, just the tut letter 101 that you guys have. If you don't have it, it is supposed to be under resources in your MyUnisa platform. Let's just get to the chi-square. Wait, I just want to make sure I didn't. Okay. So let's just clear this a bit so that we can just work with this. Okay. So we're working with chi-square. We look at degrees of freedom 8, and the level of significance is 1. So let's quickly let's get my draw back. Degrees of freedom of 8. Level of significance is 1%. 1% is also equal to 0.01. So let's just see. We want to get to that level of significance, 0.01. So where it crosses, let's just hope that is 8, and it's that one, so 20.090 or 20.09. Let's quickly 20,090. So option B. Okay, very important as well with a chi-square. We're not saying significance divided by 2. So remember when we do t-distribution, we've got the degrees of freedom and the alpha divided by 2. But with this, you can see here it's degrees of freedom and only alpha. So not alpha divided by 2. So just remember that one as well, because it might be when we say that divided by 2, that there is another number for us. Luckily this time not, but let's just quickly check where the other numbers comes from. 18, so there was a 18,47. So if you, okay, that is interesting. So let's quickly see 8. So if we set, okay, there wouldn't have been 1. Okay, so it might just be some other random numbers, or there's a 18. Is the other 18 somewhere? Okay, so it's not always 100. Okay, so there was the 18.307, but it doesn't always need to make sense how they got to the other options. Okay, just again important, level of significance, the 1%, we don't divide it by 2, it stays 1. It's only with a t-distribution in study units 7, 8, 9 that we look at that. With chi-square, it stays alpha. Okay, so here we get a bit of more work that we need to do. So the following 2x3 continuously table contains observed frequencies and expected frequencies for a sample of 364 observations. Calculate the chi-squared test statistic required to test the independence. Okay, so now we need to do this sum. So we need to basically do this calculation. Okay, so it is quite a lot of work if you are going to do it by hand, because then you need to say that minus that number in brackets to the power of 2 divided by the number in brackets. So again, I will use Excel even if it is not pre-populated. I'm still waiting for answer. So even if it is not pre-populated, you can much easier do this in the exam by just typing in the numbers so that you can work it out. So let's quickly do that. And I'm now not even going to do any formulas, so that you can just see how I would have done it in the exam if we were not allowed to pre-populate it. I would have just put in all these numbers as they have given it to us. So that has not taken us that long. And then I will just say in this block, I'm just going to do what I need to do with that formula. So it's for observed minus the expected to the power of 2. And let's just make sure that Excel sees that as a formula divided by the expected. Okay, so, and then again, observed minus expected to the power of 2 divided by the expected. Exactly the same there, and there, and with that one. So I will share this with you guys as well. Then I would just say the sum of those numbers. And hopefully there is one that is linked to it, 9,4. So if we round this off, okay, so 9,41, 9,40. So option D would be my answer. Okay, so I haven't now gone to work out totals and then with the totals set up the spreadsheet so that it automatically works out, because that's not needed. So if this was in the exam, they give you the numbers. So then I would just use that numbers and put it in Excel, and work it out. What if you don't have access to Excel, then you will need to do the full process, but that's why they will give you the observed number. So they're not going to, and most likely in the exam with less time, they will not go to this level. Different with the assignment where you've got more time, but in the exam, they will not give you 6 numbers to work out. They will also not give you observed that you now first need to, sorry, the expected. Now that you still need to work out the expected. Okay, so that is, they will not do that. So if you needed to do it by hand, it is a much longer process. So you would have needed to work out the observed minus the expected to the power of 2 divided by the expected number. And then you would have needed to do that sum for this combination, the CP combination, the QA, QB, and QC, and then sum all of them. And then you will get option D. Okay, so it will then be something that you don't need to worry that in the exam now suddenly you need to be able to do this in 2 minutes or something like that. It will not happen. Okay, so in the exam it will be much more that they might give you certain things and you need to say what is happening. Okay, so let's look at the next question. Okay, so let's read this question, and hope it is something to do with his 2 study units. Consider Okay, contingency table. Below to test the independence between the distance from home to school and the school level. Okay, what is the expected frequency? So where is my original table? So what is the expected frequency? So we can work out that one. Of high school learners traveling between 3 and 6 kilometers from home. 3 to 6. Okay, so we need to find out or work out what is that expected frequency. So the observed frequency is 120. We need to work out what is the expected frequency. Okay, so automatically when I look at these numbers, you can't have a 0.12. And so option C is not possible. Okay, all the others is possible. So what we first need to do is to check, okay, we need to have a row total. So we need to know what is that row total. Then we will need to know what is the column total. And they didn't say, so we also need to know what is your total in. And so row, column, and your total in. So that is the three things we need to work out. So let me get my calculator. So the first one, easier to just get the two numbers added together. So 210 plus 120. So the total for the column is 350. And let's then add across to see the 75 plus 120 plus 165 gives me 360. So that is 360. And I still need the total as well. So let's just add all of them together. So 115 plus 210 plus 315 plus 75 plus 120 plus 165. Okay, 1,000. Okay, so then how to work it out. So the frequency of that is the row total, 360, times the column total, 350, divided by 1,000. Okay, so that is 360 times 350 divided by 1,000. Okay, which is weird, 118.8. So if we round that off, so I would have been happy with 118.8, but obviously they round it off to 2 decimals. So, to no decimals, to for whole numbers. So our final answer then is 119. Okay, so again, they will not give you an option that one is 118 and one of the others is 119. So normally they go with a decimal number, but in this instance, they wanted the whole number. Okay, so that is how we would have worked out this expected value. Just be careful as well. Sometimes they give you all of this, and then they might even ask you to tell what is the observed number, just to see if you know what is the difference between observed and expected. So again, just be very careful when you guys are doing this, that they don't caught you off guard by now suddenly just asking what is the observed number and giving that as one of the options. Okay. I think we looked at something like this the previous time when we looked at study unit 11, but let's just go through this again, because I've added some ones that we was in previous exam papers for you as well. So just that you see a bit of all the different things that are there. So the reading speed estimated regression equation of learners of my secondary school is reading speed is equal to 13.1 times age plus 61.9 with a correlation coefficient of 686. Which one of the following statements is incorrect? Okay, a 17-year-old learner is expected to have a reading speed of 298. Okay, so what we need to do here is we need to solve reading speed. What we have is they tell us how old the learner is. So we know then that the age is 17. So it's 13.1 times the 17 of age plus 61.9. Okay, so if we then work out that number, if it is 298, then we know our answer is correct. If it is not 298, then we know it is incorrect, and that is the one that we wanted to pick. Okay, so 13.1 times 17 is 222.7 plus 61.9 gives you the 284.6. Okay, so it is not the 298 that they said, so obviously that one is incorrect, and we wanted the incorrect one. So in the exam, you will pick that. Don't worry about the rest. Go on and go to the next question. Okay, so in the exam, if you get that, then don't worry about the rest. You have worked it out correctly. Let's just look at the other options as well. So option B, there is a moderate positive linear relationship. Okay, so the R is positive, so that is why we can say it's a positive linear. That for me is already moving towards strong, but moderate is also fine. So you will, some textbooks go and say, if you are below 0.5, it is weak. If it is more than 0.5, it is strong. Then other textbooks divide it into 3 areas, where they basically go from 0.1 to 0.4, 0.4 to around 0.7, and then from 0.7 plus. And then that would have been weak, moderate, and strong. Okay, so again, different textbook, different YouTube sources have different ways of saying how, to what extent the positive linear relationship is. But more important is to focus on the positive linear and not to say negative. So there might again be an option for them to give some of the options to say it is a negative linear relationship, that you need to pick that one as the incorrect one. Then option 3 or option C, a year increase in a learner's age increases the reading speed by 13.1. And here we can see in the formula. So if we needed to rewrite that as a linear or algebraic formula without nearly putting in the words, it would have been y is equal to 13.1x plus 61.9. So we know with each increase in year, there will be a 13.1 increase in reading speed. The same what we can say is that for each decrease in year, there's also 13.1 decrease in speed. So it goes both ways. So yes, as age increases, so let's say that was age, and that is speed. So as age increases, the speed increases, but also as age decreases, speed decreases. So, and again, if you're looking at the speed of a 10-year-old versus the speed of a 17-year-old, the 17-year-old will read quicker. So it is both ways a linear regression. And then the last one is what they say, 47.1% of a total variation in reading speed can be explained by the variation age. So total variation is R square. And so we need to check for R square. We know what R is. They told us it is 0.686. So for R square, it is 0.686 to the power of 2. Let's work that out. So if we say 0.686 to the power of 2, we will get 0.41 or 471. Sorry, and then if you put that into a percentage, you will get the 47.1%. So 47.1% of a total variation is explained by the variation in age, and how we get to that is basically to look at your R square. So your coefficient of determination is actually also looking at that total variation. Okay. I think we have done this last time, but again, just good to refresh on this one. The same with this question. So consider the observed and predicted reading speed for Kiwa Middle School. Use the given information to calculate the sum of square due to the error and choose the correct answer from a list of options below. Okay, so once again, this is not something that they will ask you in the exam, but definitely an assignment question of this there might be, because again, this is something that does take a bit of time. So let us just again quickly put in the formula to work that out, so that we just make 100% sure about that, because there is a formula to work out the prediction. Let's quickly see where it was. Okay, so it's that one, but I think if I copy it in, okay, we have not. So let me just quickly copy that in for you guys. But again, just the piece that we need. Okay, so that's the component that we need. So what we basically need to do is to say we need to work out for each of these points the error number, and then we need to sum all of those points. Okay, so you could have done this by saying 178 minus 180.36. What we will need to add here is to the power of 2. So you could have done that manually, but then again, you would have needed to say 178 minus 180.36, which is minus 2.36, but then you needed to still do to a power of 2 and then do it for all of them. So again, something like this does take time. Then again, I would rather, and not to, again, to the point that we need to program anything. It is just to look at the numbers, and to put that into a spreadsheet so that Excel does the maths component for me, so that I don't need to spend too much time on this. Important as well with these questions or these, when you work it out, as easy as it is to make a mistake writing it by hand, so easy it is to also make a mistake by typing in a wrong number. So what I normally also do when I work in Excel, specifically on these questions, is put in the numbers and just then make 100% sure that you have put in the right numbers. So then just double check your answers, because it's very easy now to, out of this, make a simple mistake. And when your answer is wrong and when you don't know how you got to the wrong answer, exactly the same if it was pen and paper. So 178, so I'm just first going down. 178, 274, 155, 207, 208, 184, 224, 196, 246. Okay, and then that one. And especially where there's repeats, one can very easily think that you have made a mistake in the repeat. Let's see. So if we then do the sum of that, hopefully one of these numbers is what we're looking for. Okay, again, round it off. So if they round it off, I will also then go and round it off. So 2633, go 2633. Okay, so basically what we needed to do is take the y, subtracted the predicted y value for each of them. So you need to sum all of them. Okay, and then you will get to the 2633. But again, very easily by hand or by Excel to make the mistake originally when you capture the data. Um, then in Excel, a bit easier if you set up your formula that you just drag through, then it's a bit easier to get to the answer than now to do that for everyone and then still add everything together. Okay, let me just put in here as well. I will share this in any case with you as well, so that you can also just practice it. So if something like that does come up, you do know how to then calculate it. What you can also test is if you have a scientific or financial calculator and you can put in X and Y's, there will not be a problem if on your calculator you use this as a X and a Y, and then you treat it as a X minus a Y. Okay, so I will check for you just on the calculator how we can do that as well. And I think most of you guys have sharps and cashiers, so I will just check if there is another shortcut on the calculator to do it if you get this type of data set. So I have made a note now. So let me check. Um, if you have something different than a Casio or Sharp, let me know in the chat, and then I will just check for those calculators as well, if there's not another shortcut how to do it. Okay, then the last two questions is from previous exam papers. So this was from papers when it was still hard copy papers that you needed to write in a venue. So here you can see a question on a regression was interesting. It was, look at that, this was for 1 year and this was the second year. So very similar to what is happening with a lot of your questions. They do repeat questions. Okay, so let's look at these options, and when I ask which one is incorrect. Okay, so consider the two variables in a regression equation. Then y is equal to 1.125 plus 0.37x. The incorrect statement is, okay, independent variable is x. So that is always the case if a formula is set like this. The independent variable is linked to the slope. The dependent variable is the one that you are working out. So the y is the dependent variable. So those two are nearly always x independent, y is your dependent variable. Slope is 0.375. So we look at that formula. That is our slope. That will be our y-intercept. So slope is 0.375, correct. There is a relationship between x and y. Okay, so if you look at this, you put in a number 1 in x, you get a y number. So there is a relationship between the two. They haven't told us it's a positive relationship, it's a negative relationship, it is strong, weak, moderate. They just tell us there is a relationship between x and y. So that is correct. What will the relationship be? So that is a question for you guys. Will it be positive or negative? And you can put it in the chat what you think, or is there not enough information? So is it positive, negative, or we don't have enough information? What would you have said if they've asked us that question with that formula? Okay, so let's quickly check. They don't give us R. So nearly the first thing is they don't give us R, so I don't know. But remember, the sign of your slope is the same as the sign of R. So even if they didn't give us R, the sign of the slope is positive. So because that is positive, our relationship will also be positive. Okay, so they, and that can be a trick question or a question that they want to catch you out with by they don't need to give you R or the value of R or the sign of R. If they've given us what the slope is, the sign of a slope is exactly the same sign of the R. Okay. We can't, with this formula, say if it is weak, strong, or anything like that. For that, they need to give us the value of R, but they could have asked us if it is positive or negative by just referencing to the slope of this formula. Okay, then the last one, they say the estimated value of y when x is 0 is 0,375. Okay, so that will be the wrong one. And the reason for that is, so y, the estimated value for y when x is 0 and so when it's 0, so that component will be 0. But what we are left with is the 1,125. Okay. So the estimated value, what we're looking for is actually 1,125 and not the 0,375. Okay, so a bit different question, but I think this was like 2018 question. And then the year after that, look at that, exactly the same formula, and then some differences in the questions, but not a lot of big difference. So again, which one is incorrect? So firstly, x is always independent, so we're happy with that. The dependence is y, happy with that. Slope, okay, we know that is the slope. So this is not the slope, that number is y-intercept. Okay, so that is what is wrong, is the y-intercept. Look at the fourth option, exactly the same as the previous one. There's a relationship between x and y. And now suddenly, and this is a very good example of how they will ask your questions with this 2 or 3 different options that you can have as a possible answer, or as a question, because the previous one, the slope was correct and option 5 was incorrect. So the estimated value of y when x is 0. So we've seen when x is 0, the 0,375 times 0, that component will be 0. But we will add it with, 1,125. Our final answer will then be at 1,125, which in this instance is correct. So, and that's why the reason why I added these last two questions nearly for you, because this is typically how you would have seen your assignments already playing out this year. If you'd done the first assignment or the first attempt and you're doing the next attempt, the questions looks very similar, but there's one or two things that they have changed. And here in these two exams, again, very similar, but they just nearly, instead of having that as the slope, they changed it to something else. Okay, so again, just be very careful when you guys are doing the assignments. So again, this is now the last one, but if you do it more than once, just be careful that you don't think, oh, it's the same question that I had the previous time. It might be that there is a slight difference and you need to pick a different answer. Okay, guys, this is a quick recap of study unit 10 and 11. So chi-square, we've looked at nearly all of so if we look at this table, nearly all of the things that we need to be able to do. We've looked at how to look at the chi-square table that is in your study guide, or in your TUT lecture. I think there might be even one in the textbook if you have a textbook, but don't worry too much about that. And then on the regression side for tonight, we basically looked at, if I give you a regression line, how to interpret it a bit. Then we looked at the previous exam question, also just to look at a bit of interpretation, and then one around working out the predictive value or the SSE that you need to work out the square sum of error. And also the reason why I included the SSE one, the square sum of error, is also we have, it's not really, when you go through your study guide, this is not really something that is mentioned somewhere in the study guide. It's not part of those list of formulas in your study guide. So that's why I just thought again to put this into tonight's prep. I will also then look at the assignment 5 prep that you guys have received, I think yesterday or the day before, and on Sunday morning we will work through that one, just so that you get enough time to prep for this last assignment. And then again, as usual, I will ask the lecturer if there is not yet an extension, just to extend it to longer on Monday, so that you can still be able to, after work, get the session into to try it, because again, that is important to do that. Okay, so that is it for tonight, everyone. Um, it was a short session, but I think we covered what is needed. And then we will just again on Sunday just do a recap on this again so that you have enough of this to be able um, to get through that last assignment. And then scary enough, but then from next week, Thursday, we will start doing exam prep. It feels a bit weird, but yeah, next week we'll start exam prep. So we will go back to study unit 1 and work through